So we've already talked about domain and range. What we're adding in today is finding a reasonable domain and range. In other words, you might have to determine, what kind of domain and what kind of range makes sense to this problem. What's domain again? What is it called? All the x values. Yeah, all the things that x can be are in the domain. How about the range? What's the range then?
Everything in the y value.
All the y values, anything y can be makes up part of the range. So when it says reasonable, basically they're saying, you know what, are there maybe some times when it would not make sense for this to be an x value? It would not make sense for this to be a y value. So that's when they're talking about reasonable. You need to think a little more critically and decide, I just can't, plop down some numbers. I better think it through. Does it make sense that that would be the answer? So we need to decide, it looks like right here, I want you to tell me, we're going to determine first of all in this problem, what's the independent and what's the dependent variable? So do a quick glance through that problem again. See if you think you can figure out what are the two things that are kind of like unknown in this, and which one is the controlling one, and which one's the result, which one's the independent, which one's the dependent. Got any ideas, Andrea? Were you processing it for me? Okay, Seth? Got any ideas for me? You want to pass to Adam? Or did you say something that I didn't hear? Could you sit up for me, please? Huh? Oh, you want to pass to Adam then?
Sure.
Okay, Adam.
The whole numbers depend on number of watts.
The whole numbers depend upon the number of watts. Okay. What do you think, class? You want to agree with that? Want to maybe change any part of that? So it kind of sounds like there's something to do with the number of watts. Maybe the total number of watts that this heater is kicking out at a time. Are there options? Does this heater, you just plug it in and there's only one option for how many watts it puts out?
No.
Okay, and it puts out watts, and according to what? What does it put those watts out according to what?
The setting.
The setting number you choose. Anybody ever use like little electric heaters at home, little space heaters, or to help keep your bedroom a little warmer, or your basement warmer at your house, or something? Yeah. And do you get to choose, or does your heater just you plug it in and it just kicks out heat? And you gotta just deal with how much it's kicking out or how little it is. Do you get to choose? Yeah. Do you set it maybe on a low or a medium or a high or a setting number like this or whatever? Yeah. So I would think that the total number of watts. So like Adam said, we've got something to do with the, the watts. So the total number of watts that this heater is, kicking out depends on what? In this problem, what is that dependent upon? Which room of the house you put it in? The setting number used, yeah, on the setting number. So the number of watts, the total number of watts that this heater is kicking out, is using, is dependent upon what are you going to set it at. Okay, which setting number are you going to put it at? So the dependent variable is going to be what? What's the dependent variable? We just wrote it as a sentence right now. We were trying to decide what depends on what? The number of watts. So the total number of watts. And we're going to have to use the word total because there's another thing to do with watts in this problem. So the total number of watts is our dependent variable. That will be our what? What do we call the dependent variable? Y, right? And the independent variable is x. What's that going to be? Independent variable is going to be the setting number, yeah. This is huge that we can decide what are the two unknowns in this. What are the things that are going to be our independent and our dependent variable. That's how we're gonna learn how to process through word problems. We're not gonna just look at word problems as a bunch of words with some numbers in it and just pull the numbers out and throw them into a problem. I bet up to this point that hasn't gotten you real far, right? Just, saying, oh, just take this number and I'll add it to that number and then I'll get my, result. Sometimes we just, that's all we care about is there's some numbers in the problem, pull them out and try and do something with them. This helps us process through how to take the information and put it together properly. Okay? So what do you think the function rule is in this one? Remember, function rule means, what do you do to x? What are you going to do on the side where x is? That eventually will help you get to y. Go ahead and write down what you think might be a good function rule for this problem, because you won't be able to erase it with your pencil if you decide yours isn't a very good rule after we start talking about it. Write a function rule. I want everybody to write one. No equal sign, just what are we going to do to the x? No y in the function rule, no equal sign in the function rule. Read, go back to the problem if you need to read it. What do you have to do? We don't have that. No y, no f of x in it, no equal sign, just the part. What are you going to do to x? Okay, Sydney, would you share with us what the function rule is?
500 times x?
Yeah. Why are we taking 500 times the x value? Why would we take 500 times the x value? Sydney, can you expound on that, or do you want somebody else to? Oh, you do, okay. Well, there's some people over in this row that I saw had that same answer. I wonder why they did that. Why would we take 500 times the x value, the setting number? Adam?
Because each, the x is the setting numbers, and for each setting number, it would have to times 500 to each one.
Yeah, exactly. In fact, would you look in the problem and says the second sentence? Would everybody go to the second sentence? Here's our equation in words right here. The total number of watts used for each setting is 500 times the setting number. We call the setting number x. It says take it times 500. And then you should get your total watts used. So all we got to add to this is our y equals, right? The total number of watts, y, is, Sam, are you with us? 500 times x. If they told us to write it in function notation, I don't know that they do on this one. I think it says write a function to describe. Did they say function notation? No, so then we can leave it as y equals. If they say function notation, how do we write it? How would we write this instead then? Yeah, or f of x equals 500x. Either answer could show up in an answer bank. Either answer would be correct. Okay, now we're into the part, find the reasonable domain. Well, since the domain controls the situation, it gets to be first here. So, what's our domain made up of again? What's the domain in this? Domain is made up of the what? The x values, and the x values in our problem are the what?
0.
Just tell me what the x values are representing in this problem.
Setting numbers.
The setting number, not watts, the setting number. And does this heater have a bajillion setting numbers?
No, it only got 3.
Okay, what are they then? 1, 2, 3?
No, that's 4.
There's 4.
Yeah, there's 4. 0, 1, 2, 3.
Yeah, because 0 would be what?
It's not a setting.
Well,
No,
wait a
it's-
minute.
I guess it is if it's off.
Yeah, so O is, 0 is off, 1 is probably what we could call,
You're not using any power.
oh, you don't use any power when it's off. Huh, I wonder then, but is it still reasonable to have the, I mean, if we don't put 0 in there, this space heater's on all the time, isn't it? Well, I don't think so. Well, then it's still off, isn't it? Yeah. We still would have to have 0. So now that we've decided that here are the options for this space heater, 0 or unplugged as Blake says, 1, 2, and 3, we will make a table, 0, 1, 2, 3. We will put our function rule in the middle column. What are we going to do to x to get y? So 500 times 0, wonder what that is. Oh, like Blake said, well, there's no wattage if it's off. Yeah, no, there isn't. There it is. Y, total number of watts, 0. At setting 1, we're going to multiply 500 times 1, and we have how many total watts being used or kicked out, or however they talk about it? 500. Okay, go ahead and finish the table because I'm pretty confident you can do this. Without a calculator even. Okay, go ahead and list the range. What do you think the range is then? I've started the set notation for you. What's the range? Go ahead and write it. It's the reasonable range for this problem based on that reasonable domain we picked out. Preston, share with us, what's the range?
0 to 1,500. 0, 500.
Yeah, we can't state it as a compound inequality, 0 to 1,500, because are there wattages like 900? We gotta be specific. We gotta say, no, these 4 are the only choices there are for the range. Okay, is this a relation? Is this a relation?
Yes. On the Y. The Y value is not.
No, remember, is this whole setup here, is this a relation? Are we working with a relation here?
Yes.
Okay, why, Blake?
Multiply it all by 5. Each one.
What's the definition for a relation? It might be earlier notes. We should have that one down by now. What is the definition of a relation? Set of ordered pairs. Do we have a set of ordered pairs here? We do, don't we? How many ordered pairs do we have? 4. What's one of them, Andrea? What's one of the ordered pairs? 1, 5, ordered pair 1, 500. Maisie, what's another one? 2, 1,000. 2, ordered pair 2, 1,000. Seth, what's another one? Pardon? We've already talked about 1, 500, 2, 1,000, and we said there were 4 altogether. So what's another one, Seth?
3, 1,500.
Pardon? I did 3, 1,500. So ordered pair 3, 1,500. Adam, what's 0, 0? We have 4 ordered pairs. This is a relation. Okay, now is it a function? Tell me, what do you think? Do you think this relation that we just said is a relation? Do you think it's a function? Yeah? Okay. What qualification would it have to meet to be a function? Remember, it's a special relation if it's a function. What would that look like then? What has to be true? What do you think, Holly? You agree with Sam when he says he thinks, yeah, it's a function? Sydney?
Yeah.
You think it is too? Can you help us understand why maybe?
Because each x value can only determine the y value only one time.
Each x value has only one y value. And doesn't it make sense in this situation that each x value would only have one y value? Why does that make sense? Oh my, I'm making you think. Would you please think? Why does it make sense in this problem that each x value would only have one y value? Not two of the same. If you set it at, let's use 2. If you set it at 2, is it possible for it to kick out 2 different wattages? Just because it's Monday, if you set it at 2, it kicks out, 1,000. But on Friday, it kicks out a different number of wattage because you set it at 2? No. It makes sense that it's only going to have one y value because when you put it at 2, it's going to kick out how much? 1,000 watts worth of heat or whatever they call it. I don't even know. Okay, let's go to the back side. More practice. This one's not in your book, so we're going to read it here. A moving company charges $130 for truck rental plus $1.50 per mile. So that kind of sounds like a U-Haul or something, right? Okay. Identify the independent and dependent variables, and then we're going to write a function to describe the situation. Okay. So, what do you think? Say to yourself, what depends on what in this situation? Go ahead, Blake.
The total cost depends on how many miles.
Yeah, the total cost, how much it's going to cost you altogether, depends on how many miles you put on this truck, right? So the dependent variable is the total cost. And we always need to identify that. What is the independent, what is the dependent variable? It doesn't matter which order you do them in. Notice I put the dependent first only because sometimes it's easier to say, oh, this is what I should get if. And so the independent he said is if I put on so many miles, then I'll know how much it's going to cost to do it. Okay, write a function rule in your papers right now because I know you got this. Go! Write a function rule. Remember that only has x in it, no y, no f of x, no equals. What do you do to x on that side that will eventually get you the total cost?
That's right then.
Okay, can I just hear some of your function rules? Because you know what I want to do, and this is not, I have no intention of trying to put anybody down. I like when you guys do things like you do because then I can say to you, let's process through what this really says. So Adam, can I just use your example, what you had there? Yeah, I know, but can I use your first example? It'll be okay? Okay, here's what Adam had, and he's fixed it now, but he has given me permission for us to analyze this. This is what he had for a function rule, x plus 1.50. Remember, what does x represent in this problem? The number of miles. So when I look at this rule, here's what it says. Take the number of miles. So if I'm moving over to Fargo, how many miles would I be putting on it? 60. So I would take the number of miles, 60, and I would add $1.50 to it. So the truck rental would be $61.50. So can you see how that does not make sense to this problem? Number of miles plus money? We can't do that. So Adam, I'm going to give you the opportunity to show us how you fixed it.
I just put 130.
That's all you put? Okay.
I
So-
don't know if I should put the X either because that would be 130 times that.
And then, you know what, and there was a, Holly, can I use your first example? Here's what Holly had the first time. And she said I could share this. So what's happening here? This is, X is the number of miles times 130. So if you move to Fargo, put 60 miles on the truck, what's 60 times 130? Somebody get the calculator handy? Huh. What's 60 times 130? 7,800 dollars. That seem reasonable? $300 plus $1.50 every mile. It somehow got up to $7,800. Ooh, I better start walking my stuff over farther. So that, so that is, so we got to process through what's happening when you do that. So, who wants to have Samuel?
130 plus $1.50.
Okay, so I'm gonna write it over here. 130 it was, plus $1.50 X. Okay, so now let's process through this one. This says you're gonna pay $130 plus $1.50 for times the number of miles that you drive it. So 60 miles times $1.50. Anybody know what that is? 60 miles times $1.50. $90. Yeah, does that make sense? If you pay $90 and then add 130 to it, $220. Does that seem a little more reasonable to rent this truck to move? This is the correct function rule. We do take the $130 that we only pay once, and then we add to it how much this is money too, because when we take $1.50 times the number of miles, we know how much money we have to pay altogether according to those miles. So now we can set it equal to y and say, you know what, if you want to figure out, like we just did, how much it will cost you, substitute in your x value and you will get your y value, and it will be a reasonable one. Okay. Well, now we have to, it says, what are reasonable values for the domain and the range in this situation? So domain, let's think about that one first. Domain. Capital D. Domain is representing what? Domain is representing the x values. The x values are representing x. Look up above. X values are representing number of miles. Can you think of anything that would not make sense when you talk about the number of miles? That's what reasonable means. You've got to think it through. Is there anything that does not seem reasonable when I'm thinking about putting miles on this truck? 100,000 miles, that seems unreasonable. Because you don't want to just keep driving around the country. Or could you?
Well, you could.
You could. But what? Yeah, it would. It would be pretty costly. You're right. Whew. Just driving, and driving, just can't make up your mind where you want to stop and settle, drop your things off. You just got to keep driving. Well, but is there any reason that you couldn't? Okay, well then I'm gonna say that if you wanna rent this truck and put 100,000 miles on it, you can.
Think on the other end of the number line.
Can you have negative miles? Can you say to the truck company, well, you know what, I went south, or I went, if I go south, or I went west, so then that means I was going in the negative direction, so I went a negative, I moved to, so I went a negative number mile. West, by the way, is this way, of course, but I went west, so I moved out to Bismarck, it was 130 miles, so it's a negative 130 miles I put on the truck, because I went, on the number line, west would actually be negative. Do you think they're going to call for that? No. Can you have negative miles? No. Okay. What do you think we can have then?
But
Only positive miles.
you could do something that counts as fraud, you can turn back the miles.
Yeah, that you could do. You're right. You could. I'm not sure how we'd write the equation for that though. But you could do that. We would not want to do that though, because we're moral, upstanding North Dakotans who don't do things like that. So I'm thinking that we're going to write this as an inequality. All the numbers have to be, what kind of a number? Positive. X is greater than 0. How about could it be equal to 0? How do you feel about that? I mean, could a person really, like here's what they did. They rented the truck. They loaded the whole thing up. They got a call from their mom, and their mom was just crying her eyes out. She says, you can't leave me. You can't leave now. So you never even drove it. You unpacked the thing and you stayed in Mountain City. Could you put no miles on it?
Yes.
Yeah, so I guess we're going to include 0. Okay, so the domain, a reasonable domain is x is greater than or equal to 0. So, and we're just going to make this little note. Why did we say that? Cannot have negative miles. You know what? This is what helped us decide that a reasonable domain for this is we got to have all numbers greater than or equal to 0, because there isn't such a thing as negative miles. No fraud's going to happen in our lives. Okay, a reasonable range. Based on our domain, what do you think is going to happen with our y values? So if we did that, we packed up this truck, didn't even take it out of the driveway, and then we unloaded the whole thing. We didn't put any miles on it. How much would it cost us?
130.
Okay, let's think about this up here. If we don't put any miles on it, 0 miles. 0 times $1.50 is 0. But we signed the agreement. We rented the truck. So how much is it going to cost us? $130, whether we take it anywhere or not. We've already signed the contract. We got that truck there. We are already paying for it. So we're going to start at 130, right? It can't be any less than that.
You're still gonna have some.
You would have miles on it because you drove it to your house.
Okay, so you know what we'll do? Here's what we'll do then. We will erase this equal sign because you know what? You got to put some miles on to drive it to your house. I will agree with that. Yeah, you're right. So unless you're the truck rental company, I guess that would be true. So now it's greater than 0. So what's going to be true? So we're going to put some miles on it.
Y is less than or equal, is
Doesn't it still
greater than or equal, just equal to 130.
Let's try this. If it was greater than 130, that means we paid the 130 plus we put some miles on it, right?
Mhm.
If it's equal to 130, what's that say again? We didn't put any miles on it, but you guys just said we have to drive it to our house, right? So can we have the equal to bar on this one either?
No.
No, you can't have it in this one either, so, okay. So we are going to say, without putting any miles on it, without any miles, well, we know that there's a little bit. Without any miles, it still costs $130. So that's kind of why we make that our end point. It still starts at $130 and then it goes up from there. But you guys convinced we can't have it just be 130 because we have to drive it to our house. Okay, how much will it cost if you rent the truck for 200 miles? $430. How'd you get that, Andrea? 200, multiply 200 what? Times the 150? And then added the 130. And that should give us our, so in other words, we're using our equation here, aren't we? Here's our equation, just substituting in the 200 miles. So y equals 130 plus, what's 2 times $1.50? Oh, come on, no, don't you even think about it. You give $1.50 to somebody, you give another $1.50 to somebody, how much money have you given away? $3, and then times 100. Well, we got that decimal point though there, so remember, so 3, it's $3, so how much, 3 times 2 times 100 is what? 600. No, actually we already doubled it, remember, 2 times $1.50 is 3, and then we have to take it times 100 more, so 300. I think I just confused you more, I'm sorry. And what did you say, Andrea? Did you say the answer was 430? Yeah, 430 miles? Dollars. $430. We use our equation to get it. Okay. Could we use this equation also if we knew how much money we had to spend and figure out how many miles we could put on the truck? Could we use it that way also? What if you had $1,000 to spend? Where would you put the $1,000 into your equation? $1,000 for moving. Preston's eyes are already lighting up. He just wants to start thinking of ways to spend it. $1,000 for moving.
Vegas.
Where would you put the 1,000 in that? In the equation, y equals 130 plus 1.50x. Oh, I give up. Okay, I'm done.